time. We really a minute is all you want to spend per problem. So I would encourage the following sort of decision tree when you're looking at a question. So the first, and this is the best case, is I know it, I can solve it. That's the absolute best case. And when I say solve it, we're talking about 60 seconds. The second best case, which I hope this doesn't happen, is I have no idea. I'm going to guess and move on. Okay. I call this the second best case because you're not going to take up much time. Now there's the possibility that you may be able to come back to it, but I put those into another category. So those other problems are, think I know it. Okay. And that's I think most of the questions are going to be, I know it, I can solve it. I think I know it, I just need some time. Um, some of the other possibility is like not sure, but maybe time will help. And you have to make this decision pretty quickly because you don't want to waste time on questions never be able to solve and they just take you lots of time. You also tend to not go back is the reality. The reality is like you might think you'll go back, but then you'll run out of time, and then you'll wish you had just guessed and moved on. So, you can vary this strategy for yourself, but we obviously want most of it we want to be here. Okay. And then hopefully because of the student the ones where you're feeling pretty good about it, you just spend um these are the most questionable ones over here where you're really unsure, but you think you'll have enough time to help. That those are the ones to come back to. And hopefully most of your time is spent here in 1 and 2 when you're taking the exam. But if I could do it over again, a strategy for the exam. Where it is. I'm gonna do them all in order. I'm gonna throw all the questions first. I'm going to, close my in between questions to reset. Whatever it is, you need some sort of a strategy for your exam. So I don't know if you spend any time thinking about that, but I would definitely spend some time now, not, Saturday morning on the drive over thinking about that. And that 60-second rule is a good one. Hopefully there's a clock in the room. But I think you've been doing really good at like figuring that out internally. All right. So today I thought we would start out with parallel and perpendicular lines. What do you remember about the slope of parallel lines?
They're the same.
They're the same. Yeah. Do you remember anything about the slopes of perpendicular lines? Or maybe we'll do an
Opposites?
example. Let's say the slope of, they are opposite in sign. Flip. So sometimes you see words like this, like opposite, reciprocal. I like flip, negate. Okay, so let's do it. Let's do a couple more here. Let's say the slope is minus 5/2. The perpendicular slope, like you said, you flip it, but you also negate it. So it would be 2/5. Let's say the slope is -3. What would the flip of that be?
Um, -1/3.
So 1/3, but then you change the sign. So one's positive, one's negative.
Oh, okay.
The other thing that's kind of interesting is if you multiply together, you always get -1. that could also be useful there. But this opposite reciprocal flip negate, whichever one, you have to be able to do that to answer these questions. And really important to figure out like are they parallel? Are they perpendicular? That's the key word you're looking for here. So let's start out with a relatively straightforward question here. All right. It says here in the L has a slope of 2. Line K is perpendicular to line L. That's important. Okay. And contains the point 4 comma 2, which of the following is an equation of line A? Go ahead and give this one a try, please.
Calculator or no calculator question?
The calculator, I don't think you need it, but if you're welcome to for us, I mean,
Because the contains point 42 always throws me off with these questions.
can you eliminate any of the answers based on the slope, perpendicular slope? The slope is 2. What is the perpendicular slope?
-1/2.
Okay, so can you eliminate any answers?
Yeah, the first two.
Okay. Now, 4, 2 just means that's the X, that's the Y. It has to work in which equation does it work in?
D.
Yes, letter D. All right, very good.
How does the point 4 comma 2 affect the equation?
Uh, there's if I draw a line, there's a lot of perpendicular lines. Okay, so the 4, 2 is just the one that happens to go through. In this case, we're saying that 2 equals -1/2 times 4 plus 4. Is this a true statement? That's what I was asking. Does this? And it does.
Okay.
But like we've talked before, there's usually something you can do to eliminate some of the answers. Is that okay?
Mm-hmm.
All right. Let's look at a parallel problem here. Parallel. All right. So which of the following equations represents a line that is parallel to the line with this equation? What's the slope of this equation?
Oh, -3.
-3. So notice none of the other equations are in the right form to get the slope. So you want to solve for y. You really want them all in y equals mx plus b form. So you can start with the first one, the last one, the middle one, but one of them will have a slope of -3.
And we wanted to have a slope of -3, or
Yes, because it's parallel. We're looking for parallel this time. Parallel lines have the same slope.
B. B.
Okay, so when I solve b, let me go over here and do that. 3x minus y equals 7. If you subtract 3x from both sides, you get minus y equals -3x plus 7. Divide by -1. Y equals 3x minus 7. Does that have the same slope?
No.
No. So you have to fully solve it for y, no negatives in front, so it's not b. It's not b.
it's not deep and A.
Yeah. So there is kind of a shortcut here if you want it, which is if it's an ax plus by equals c form, which is standard form. Okay, if you solve this for y ends up being minus a over b times x equals c over b. So you could remember that if you really wanted to. I think it's pretty specific, but it could be useful. Um, I'm not I'm not here to discount um, any of these things, but you're going to get something with parallel and perpendicular lines on the exam. That's a guarantee. Now, the reason that might be useful is in the following equation, because this equation requires you to use to convert all of them from standard form into this form. So this might be useful. And also notice that this is important too. The uh, the constant is not important. Like you should ignore the constant. Don't even try to calculate it. Don't divide that. Don't worry about that. All right, so here's a new question for you to think about. That slope equals minus a over b could be useful here. I'll throw that in here. Go ahead and give this one a try, please.
would be 2/3.
The Are you asking
F.
about the slope of the original?
Yeah.
Yeah, the slope of the original is 2/3 for sure. So what is the perpendicular slope? That's what
Um,
we're looking for here.
-3/2.
Yes. So now which of these has that?
A.
Yes. Do you think you're going to try to remember this formula?
Yeah.
Okay. Wouldn't be a bad idea.
It seems
Um,
helpful.
I don't show this to most students because it's like just yet another thing to remember, but it's if you look at enough of these, you realize, they're all kind of the same. Okay. They are not all they're not all multiple choice. Here is a free response question for you to think about.
One-eighth.
Okay. Now, in terms of how you would enter it, just a reminder, I think we've already done this, but there's actually three ways you can enter this one. 1/8, 1/8, 0.125. Make sure you fill in the bubbles. Um, Notice again, there's no zero in the first position and there's no negatives. So if you get a negative, that's a mistake. All right, you're doing great.
So
Yeah, you go ahead.
for um, if it was like a whole number, would we write it left to right and then leave the extra spots
Yeah,
blank?
yes, exactly. Exactly.
Okay.
Like what you're asking is, I'll just use a
Like if
Yeah,
the
let's
answer
say
was
the
like 36.
yeah. So there's actually, and I mean, I don't know why they do this because I think it's weird, but I mean, you could do it this way, 36, 36, or 36. I think I would prefer you to just like use the right justification if you can. I mean, that seems the most
The right
less,
one?
well, it seems the least likely to cause you any weirdness.
Okay, I was just checking just in case there was like a
They all
certain
work.
way I had to write
They,
it.
no, they all work. They all work, but try to stick to, like normal convention. Normal convention is right justified, at least in, the Western world.
Okay.
Okay. Um, let's do a couple more here. All right. Let me snip this in, get the timer ready. All right, go ahead and try this one, please.
Is it C?
Okay, how did you come up with C?
Because the y-intercept of line J is -1, and then the coordinates are 0 and 3.
Okay. So we're looking for the one that's perpendicular. Oh, sorry, perpendicular to K, right? So what's the
Mm-hmm.
slope of K?
1.
K is this one up here, right?
Yeah.
So it ends up being minus, the A value is 1, so it's -1/1. And so the slope of the perpendicular is the flip of that, which is -1.
Yeah.
I'm not saying your answer is wrong yet. I'm just asking, did you, because you said it was 1. I'm sorry. It's the
I
slope
said
perpendicular
the
to,
y-intercept of line J is -1.
right. But the y-intercept of, the y-intercept is 0, 3. Maybe you meant the slope.
Oh, sorry, yeah, the slope.
Okay. Okay, got it. All right. So C worked in terms of that. So does D. Uh, and then it's which one contains the ordered pair 0, 3. Um, problem with C is that when you write 0 minus 3, that equals, and that's supposed to equal 3. This negative goes with it. Like this ordered pair has to work in the answer.
Why would it be 0 minus 3?
Because you're putting 0 in for X and 3 in for Y in here.
Oh, okay.
So this does not work, unfortunately. Um, so like
So
the
it'd be
better way,
D.
yeah, and the better way to do these problems when you're given an ordered pair is to see which one it works in. So 0, 3 works in the first one and the last one there. Or like you may, I think what you did was using the slope, but like I like trying the ordered pair. I think it's faster to calculate that than the slope. That's just me. And then then you figure out your slope from there. Okay. It's all right. Let's keep looking at these. We'll switch to another topic here shortly, but yeah, I had a couple more of these for you to work on.
What's the equation like y1 minus y2 over equal?
it's still in standard form. Like the slopes are still minus a over b.
Oh, okay. But the equation to find slope is y1 minus y2 over x1 minus x2.
That does work. When you're given the graph though, I would just go to kind of nice points and use rise over run. While what you said does work though, it's generally written this way where it's y2, then y1, x2, then x1. But the way you said it does work either way.
D.
All right. So the original slope is 3/5. So the slope perpendicular is minus 5/3. And does that match up with, you said B, like boy?
I said C.
C. Okay. So remember the slope in this form is minus A over B. So the problem is that that would be minus 3 over minus 5. We want the one that's minus 5 or
Oh,
3. Your slope is rise over run. So
wait,
why don't you
because -5 would be the top number, right? The
yes,
numerator?
A, yeah. Remember the signs could move around. I mean, it could also be A over minus B depending on your signs.
So is y not 5?
And the number in front of Y is B. So let me do this differently. Because I guess let me just grab
Oh, so it would
the answers
be
here.
B then.
So let's go through all the answers. You can see this. Minus slope is minus A over B. So the first one's slope is minus 5 over 3. The second one's slope is minus 5 over minus 3. Minus 3 over minus 5. The last one here is minus 3 over 5. This one is 5/3. This one is 3/5. Do you follow I'm doing it? This is A and this is B.
Oh, so it'd be B.
But we want the one that's minus 5/3 because the slope is up 3, right 5. So the perpendicular is the reciprocal negate minus 5 over 3.
So A.
Yeah. What do you think? What do you think's going on here? Seemed like you had it and now it's escaped, vanished.
I thought that B was the value for Y. I mean, I thought A was,
Okay,
and then like
that'll
the
do it.
negative thing threw me off.
Yeah, I mean you negate whatever the number is. It's just negate negative of whatever it is, and B is whatever it is, including the sign. Like if it's in this case, it was minus 3. All right.
Do you think
One
you can
more.
explain that again? Like the whole, like, can you solve it and then like explain it step by step?
Sure. All right. So first thing is sometimes C is on the right. It doesn't really matter, but you can subtract C on the right if you want. So you get AX plus BY equals minus c. You can subtract ax, that goes in front. So by equals minus ax minus c. Divide by b, you're dividing everything by b. So y equals minus a over b times x minus c over b, or plus, it doesn't really matter, but this is the slope. When it's in standard form.
Okay.
Okay, one more question before we switch topics. This one really doesn't have anything to do with, this one's kind of a preliminary question, but I just put it up in front of you and see how you do on that.
For this,
Question? I'm not hearing you.
um, I'm kind of confused on how to solve this one.
Okay, what's the slope of the given one? How much up, how much over?
5/2.
So
Oh
you're
no,
going,
two
I mean,
fifths.
yes, okay. Now, do the same thing for this one. You should be able to figure out one of the values.
Or over p minus 0.
Right. So which of those p values gives you the same slope?
10.
There you go.
Oh, okay.
All right, I'll table that one for a while here. Go on to some other questions here. So I'm going to go back to some story problems. These aren't necessarily difficult. They require you to read, and that's always a challenge. But I think you're warmed up to the extent that you need to be. So go ahead and give this one a try. It is not a calculator question, but you're welcome to use one if you feel like that would help. I'll show you how to do it without it if you aren't sure. All right, we're at about a minute. What are you thinking here?
Um, I'm almost done solving it.
Okay.
It's a B.
It is B. One of the things that's good to do is kind of like grab the numbers and kind of look at just reasonableness. Like, the commission's obviously more because it's a higher selling house. Um,
Hmm.
but C and D are like really big. They're like 2.5 times as much. This is like 4 times as much. So you wanna start like getting in the habit of like when you're looking at ratios because C is just way too large. Same with D. So this is the only even reasonable one without even using a calculator. So that's the kind of thing you're looking for when you work on some of these problems here. Now, there's also problems where it's a little bit tighter in terms of the spread of the numbers, so it doesn't always work. Here's another one for you to look at. I'm gonna just step away for 30 seconds, but I'll be right back. Okay, I am back. If you have any questions or you have an answer.
B.
Okay, how did you come up with that?
Um, it's there's you divide 400 from 20,000 and then you get 50 and then 50 times 7 is 350.
That's right. Yeah. Okay. Yeah, so I'm still circling them. Yeah, you want to be really careful here. Like this next question is not difficult, but it is something you see on there where it's easy to grab the wrong answer. So take another look at something like this.
D.
It's D. Yeah, that was fast. That's what we want. So these are the kinds of problems you want to do quickly and get them right. Couple more here.
B.
Yeah, how'd you come up with that?
I divided 0.15 by 100 and then I multiplied it by 140.
Okay. So you used a calculator. Is that right?
Yeah.
All right. When it says closest to, they are asking you to estimate, which means that you are okay. Like you could have a calculator on this problem. I don't really know. And because even the ones that are on the calculator section don't always require a calculator. Um, one of the things you should think of is that 140 grams compared to 100 grams, it's about 50% more. And 0.15, 50% of that's about 7. point zero 0.075, so about 22.5. Since 40 is less than 50, you would choose the smaller number as a way to do it without a calculator, which is actually kind of the intention here is to, when I teach this, it's to estimate
Mm-hmm.
without a calculator, but I'm okay with using one just because we're getting close to the exam. Now, not all the problems have numbers in them. Some of them introduce some variables. This is a very preliminary question, but see if you can answer this one, please.
$30.
30. All right, so a little bit more complicated problem. Take a look at.
C.
Okay, so not too bad. Let's go to some more difficult ones here. Those are just sort of get you going. And so try your best to not grab the calculator on this one. See if you can do it without the calculator, just estimation and reasonableness of your answer.
B.
It is B. Good. All right. For the next one, again, try to use estimation to at least reduce the number of answers. And if you still want to grab the calculator at the end, that's fine. But try to do, a step or two without that.
So use like estimation for this one too.
If you can, yeah, as much estimation as you can. Like maybe you can get it down to two answers by just estimating. Can you get it
Seven
done? Can you
thousand
get
six
that?
hundred ninety.
Yeah, so I was hoping you could get it down to A and B without
Yeah.
that. And then one of the issues I have here is that they don't really the true answer, if you think of like 630,000 divided by 90, around 7,000, it's like, it's kind of in between, and you got to be really careful when you get something like that. So that one's probably a calculator problem, so I don't love it. I'd like to see, like, I would have liked to see one of the answers be a little further away so that it was clear, which one it is. All right, here's a new problem for you to try.
B.
I heard B. Okay, good. Let's see if we can get one more in here. You can typically always do something to eliminate some answers. If you're got your numbers lined up on this one, you should be able to eliminate two of the answers pretty quickly. And then maybe grab a calculator. So what I was hoping you would see is that B has to be smaller than 54. Eliminating those two answers. And while you could use a calculator, this is closer to half. So the one that's
So it'd be
closer to half.
32.
Yeah. And a lot of the problems can be solved that way. It really can be. So, all right, we're going to stop here